Section 1.3 is on functions. So sometimes it's easier to show someone what a function is by a picture. So if we look at these first three graphs, we have functions. If we look at these next three graphs, these are not functions. So as we're looking very carefully at all of these graphs, can you tell me what the difference between those that are functions is compared to those that are not functions? If we would draw a vertical line through any of these graphs that are functions, we see that it simply touches the graph at one point. But if we draw a vertical line through these graphs that are not functions, it touches at more than 1 point. This one at 2 points. This one at 2 points. This one at 1, 2, 3 points. So now, by knowing that, can you tell me which of these are functions and which are not? A is not a function. It does not pass the vertical line test. It touches at 2 points. B is a function. It touches at only 1 point. C is a function. A vertical line touches at just 1 point. D, we have to look carefully. If I would draw my vertical lines right through here, here it would not touch and here it would touch. So this is a function. It touches the graph at only 1 point, this one. E is not a function. It touches the graph at 2 points. F is a function. A vertical line touches at 1 point. G is not a function. It touches at 2 points. So using that information, we can further define a function as exactly one y value for each x value, exactly one output for each input. Another way to state this is that no x value will repeat. The x values must be unique. If you recall from Algebra 2, when we use function notation, we would say f of x equals y, where x is your input values, your independent variables, your domain. Y would be your output values, your dependent variables, or your range. When we have data, we can represent it in 4 different ways. First is our numerical function. When it is numerical, that simply means we're using a table. We can have a diagrammatic representation. That means we have a mapping. We can have a symbolic notation. That means we use formulas or equations. So many times you're going to run into directions that say solve symbolically. That means do your algebra. And the 4th kind of representation of data is graphical, like our scatter plot. So from that, can you tell which of these are functions and which are not? And why? So what the directions say is it a function or a relation? What is its domain and range, and how do you know it's a function or relation? So here's A and B are both diagrammatic. They are mappings. So for many people, when you have a mapping, they find it easier to create the X, Y point. So in this one, my -3 goes to -2. So it is -3, -2. 2 goes to 3. So it is 2, 3. 3 maps onto 1. So it is 3, 1. So these are my X values, and these are my Y values. So my X's are -3, 2, 3. They are unique, do not repeat. So this is a function since no X value repeats. Then it asks for domain and range. Remember, domain are your X values, so you will list that. X equals a -3, 2, and 3. Range are your Y values, so you will write Y equals and list those. -2, 3, and 1. Remember, if any values repeat, we just list them once. Okay, let's do the same thing with B. First of all, is it a function or a relation? So let's see what our mapping tells us. -3 maps to -1. -1 maps to 1. -1 maps to 3. And 1 maps to 3. Again, these would be my X's and these would be my Y's. -3, -1, -1. Oh, not a function. X equals -1 repeats. That is why it is not a function. The domain, X equals a -3, a -1, and a 1. Range, Y equals -1, 1, and 3. Next, we have a numeric representation because this is like a table of X's and Y's. So is this a relation or a function? Look at these X's, -1, 1, 1. There's a repeat, so it is not a function. It is a relation since X equals 1 repeats. The domain is X equals a -1, a 1, and a 2. The range, Y equals 2, 3, 2, I don't need to repeat that, and a -1. Next, we have a graphical representation. Is this a relation or a function? And I would say a function since it passes the vertical line test. The domain, my X values used. So my first X value used is right here, left to right, -4. My last X value used is 1, and it is all the values in between. So we say -4 is less than or equal to X, which is less than or equal to -1. So then my range are my Y values from here to here. 0 is less than or equal to Y, which is less than or equal to 1. All right. What if I change my mind and instead I want this graph? It is still a function because it still passes the vertical line test, but now my domain becomes all the values to the right of negative 4. So x is greater than or equal to negative 4, since it is a closed point here at negative 4. And my range then becomes from here up. So y is greater than or equal to 0. Well, what if I still change my mind? This is actually what I wanted. It's still a function because it still passes the vertical line test, but in this case, the domain is x is all reals, and the range is y is all reals. Graph the function f of x equals negative x minus 1. So I pick the points, negative 2, negative 1, negative 3, negative 4, negative 5. So I'm just going to substitute those in. When I substitute a negative 2 in here, I get the opposite of a negative 2 minus 1. That would be 2 minus 1 is 1. So negative 2, 1, we're going to plot. The opposite of a negative 1 minus 1 would be 1 minus 1 would be 0. So I'm going to plot. The opposite of a negative 3 minus 1 would be 3 minus 1, which would be 2. Negative 3, 2. Plot. The opposite of a negative 4 minus 1 would be 4 minus 1, which would be 3. Negative 4, 3. And the opposite of a negative 5 minus 1 is 5 minus 1, which is 4. Negative 5, 4. So now I know it is these points. Now it also says give me a verbal representation. So this is my verbal representation. The function f takes the opposite of x, which is my independent variable, and then subtracts 1 to produce an output of y, my dependent variable. Now, not everyone would say that interpretation the same way. I would have some people say the function f takes the opposite of x and subtracts 1 to get the y value. Others would say the function f takes the negative of x, subtracts 1 to get the y's. All are correct. You just need to be very descriptive in your verbal representations. Now these next directions say evaluate. So that means we're going to find the value of a function at some given x value. Well, it says evaluate f of 3 and f of negative 2. So first we will do f of 3. So we are going to substitute 3 into all of these x spots. So we'd have 3 squared plus 4 times 3 minus 1, which is 9 plus 12 minus 1, which is 21 minus 1, which is 20. So when I evaluate the function at 3, I get 20. Another way I could represent this answer is x was 3, y was 20. It also said to do f of negative 2. So it would be a negative 2 squared plus 4 times a negative 2 minus 1. That is 4 minus 8 minus 1. Negative 4 minus 1. Negative 5. So in this case, when x is negative 2, y is negative 5. In the next function, f of x equals negative 3x plus 4. Well, f of 3 would be negative 3 times 3 plus 4, negative 9 plus 4, negative 5. And then f of negative 2. Negative 3 times negative 2 plus 4. 6 plus 4, 10. It says graph each function, then state the domain and range. So in this first one, I'm going to put in 0. So 0 squared plus 4 times 0 minus 1 is negative 1. So 0, negative 1. Negative 1 squared plus 4 times negative 1 minus 1. That is 1 minus 4 is negative 3 minus 1 is negative 4. Negative 1, negative 4. I'm going to put negative 2 in there. A negative 2 squared is 4. 4 times negative 2 is minus 8 minus 1. That is negative 5. Negative 2, negative 5. When I put 4 in there, negative 4 squared is 16, plus 4 times negative 4 is minus 16, minus 1 is negative 1. Negative 4, negative 1. And I get this graph. So my domain are my x values, my range are my y values. So when it comes to x values, is this x used? Yep, it just happens to be way up here. Is this one? Yes, 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 yes. So x is all reals. I can substitute any number on the number line into this function. My range, I'm going to go from smallest to largest. Is this point used? No. Is this one? No. Is this one? Yep. So y is greater than or equal to negative 5. So negative 5 is the first y used, and all of them above. Function or not, y, state the domain and range. So this first one is a function because it passes the vertical line test. The domain, my x right here is 3 and to the right. So x is greater than or equal to 3. My range, here is 0 and up. Y is greater than or equal to 0. This one is not a function. It fails the vertical line test. Right here, give me 2 points. Domain and range. My domain is, let's see what x's are used. This x to this x. So I have x is less than or equal to 5, which is less than or equal to 1. My range is from here to here. Negative 2 is less than or equal to y, which is less than or equal to 2. Again, same questions, function or not. If I put in, this one reads x equals y squared plus 1. So my input are y squareds. So if I put a 2 in there, 2 squared is 4 plus 1 gives me 5. If I put a negative 2 in there, negative 2 squared is 4 plus 1 is 5. So you notice I get the same x value. So this is not a function since x values repeat. But how about if it's y equals x squared plus 1? Well, if I put 5 in there, I would get 25 plus 1 is 26. If I put 1 in there, I get 2. Every time I'm putting in a different x, so it is a function because no x values repeat. So here's the key. It's what your x values do. This was x equals y squared versus y equals x squared. When it is not an x that is being manipulated, it is definitely not a function. Find the domains of these functions. Domains are your x values. So my basic operation here is square root. So it is always all reals except if you cannot put in every real number. So when you square root, can you square root every number on the number line? No, you can only square root positives and 0. You cannot square root negatives. So whatever you are square rooting must be positive or 0. So in this case, I am square rooting x plus 1. So x plus 1 must be greater than or equal to 0. That is how you write positive and 0. Greater than or equal. Then I'm going to solve this for x. I'm going to subtract my 1, and I get x is greater than or equal to a negative 1. That is my domain. Negative 1 and all the values bigger than it can be square rooted. Notice here, my x is in the denominator. Can you have all real numbers in a denominator? You can have anything but 0. So x cannot be 0. Well, my denominator is not just x, it is x plus 2, cannot be 0. Subtract 2, x cannot be a negative 2. Any number but negative 2 will work in the denominator. Again, this is denominator. So x squared minus 4 cannot be 0. Well, if I add 4, x squared cannot be 4. Square root, x cannot be a positive or a negative 2. All reals except 2 and negative 2.